Look.
Newton's first law. An object at rest will remain at rest unless acted upon by a force. An object in motion continues in motion with the same speed in the same direction unless acted upon by an unbalanced force. This is the law of inertia. This means that there is a natural tendency of objects to keep it on doing what they're doing. All objects resist change in their state of motion in the absence of an unbalanced force. An object in motion will maintain this state of motion. Thank you. That is example for Newton's first law. So he said that an object at rest will stay at rest, like so. There's forces acted upon it, such as gravity, but I am not pushing it or anything. It is at rest. And then an object of motion will stay at motion unless acted upon by an unbalanced force, like so.
An example of Newton's first law is this, as shown on the board. So this is a crate, which has 10 newtons pulling to the left and then 10 newtons pulling toward the right. And this is half of Newton's first law, which is an object at rest stays at rest unless acted upon by an unbalanced force. So now, when the unbalanced force part comes in, which is the second law, or not second law, the second part of Newton's first law, say that the 10 guys on the right come in, and they get another guy who's 20 newtons strong. So now, this side was acted upon by an unbalanced force, which is now pulling this side 10 newtons toward the right. This is an example of Newton's first law. Newton's second law is when acceleration is produced when a force acts on a mass. The greater the mass, the greater the amount of force needed. So basically, F equals ma, which is force equals mass times acceleration. So pushing or pulling on an object produces acceleration, a change in speed of motion, and believe it or not, an acceleration be slowed down or speed up. The heavier the object, the more amount of force is applied onto it. So that is Newton's second law.
So an example of Newton's second law would be, as such, pretend this is a smart car, and pretend this is a truck. So what would happen is if these two cars, if a truck rear-ended a smart car, the smart car would accelerate due to the fact that it has less mass, causing it to go farther and faster than it would normally go. The truck, however, will slow down because it has more mass. Even though it is hitting a small mass car, it will still slow down in the fact that it is hitting another object. This will cause it to slow down and not go as fast as a smart car, which causes the smart car to speed up and go farther away from the truck. That is an example. So, a problem for Newton's second law. The common knowledge of the beginning of a problem would be force equals mass times acceleration. So this is the normal problem for Newton's second law. But an example could be, okay, so as I was saying, an example could be similar to the truck. So this is a little his name is he is about 5 feet tall, and there's this dude coming up playing hockey, and he's big, very big. Playing hockey, you know. It's like a golf club, but you know, it's hockey. And there's a little thing, and he's pushing on him. When he pushes on JC's gonna go flying, and he's gonna go way past this guy, who will slow down because it is still mass and it is still slowing him down. Now JC, this little guy, he's gonna just go right past him, just like the smart car. And this guy's just like the truck, and he's gonna be going slower distance, but he's still going to be moving. That is an example of Newton's second law.
Today I'll be explaining Newton's third law. And that means for every action, there is an equal and opposite reaction. The statement means in every interaction, there is a pair of forces. I'm back with an real-world example of Newton's third law. As I said in the previous video, Newton's third law means for every action, there is an equal and opposite reaction. So in this, I'm just going to be using a basketball for a real life example. The equal reaction is me dropping it. Then the opposite reaction is it coming back up. So it's equal reaction, equal, and then opposite. Now another example would be if this was my basketball goal, I would be shooting it, which is my action, hitting the backboard, then coming down into the goal to score a point, which would be my opposite reaction. This is my real life example of Newton's third law. So this is my word problem or on sheet paper example for Newton's third law. So basically, just like in my real world example, I'll be using something similar. So basically, here's the ground. I have a big trampoline, and I have a person jumping on it. So now, when the person jumps up, this arrow, which means jumping up, is their initial action. Now, when they jump up, just like I said in the very first video, the opposite reaction is them coming down. Just like for the basketball, as I would throw it down, it'd be my action, and as it come up, it'd be my opposite reaction. But this is the exact opposite. Once they jump up, it's the action, and when they come down, it's the opposite reaction. That is my problem example of Newton's third law.
Yeah. Thank you, far too kind.
Yeah.
Ready?
Can I get an encore? Do you want more?
Cook and roll with the Brooklyn